And so, someone found a very interesting rule. And the fundamental of the communication is just yes or no for the closed question. So we determine the rule for the ALS patient. At first, if ALS patient if ALS patient wanted to say no, don't think anything. Don't think anything. So in that case, we cannot see any signal in the brain. And if ALS patient wants to say yes, please think something. For example, the mental calculation or sing a song like that. In that case, we can see that we can observe brain signal using this technique. And however, the other technique, please think about the other technique. There are a main neuroimaging technique, spectroscopy and electroencephalography, brainwave system, and the magnetoencephalography and the MRI. And MEG and MRI is very huge. And also the cost is very expensive. And probably EEG is very cheap. However, the EEG measures the very tiny electric signal in the brain, so it is a very weak for the outside noise, electric noise, for example, PC or radio or something like that. Now the spectroscopy is a little bit, spectroscopy has a big advantage for the against the noise, and size is very, we can make it very small, and cost is very cheap, and maintenance is free. And so we measure the real ALS patient. I will show the one movie using the.
この日、進次郎さんが最初に聞いたのは、節子さんが大好きなプロ野球の横浜ベイスターズのことでした。
今年のベイスターズの活躍が気になりますか？気になれば、イエス。諦めだったってんであればね。
She is the ALS patient, and we measured just frontal lobe using the single channel. And her husband asked so. He asked something and she gave a response.
節子さんが答えを返したのは2年半ぶりのことでした。
The number of the ALS patients is very small, but now the 50 patients are using this system to make a communication in Japan. And also they find in this session actually these are the history of the photography, and we found the principle of the photography in 1995. Then we developed a lot of type of we improved for the viewpoint of technique. And in 1998 we made a very big system. Then we made a product type of the photography. And finally we developed a digital type of the photography system. And now we developed the prototype of the wearable type of photography. Because if we get getting small device, maybe we can measure the brain function under the very natural conditions. So that's the point. And now we have this type of photography. For example, in this case, it's the simulation of the study. So he's calculating like that, and you can see the very clear optical brain signal in the frontal lobe. Okay. And also you are mathematician, so and mathematics is very important. We are thinking about it because this is the low signal of the optical topography, and this is the frequency characteristics of the optical topography, and this area is a heartbeat. This area is linear wave is the very slow movement of the blood artery movement, and also the brain activity covered in the same frequency area, and very more low frequency region include the grief and sleeping states and unknown. And if we can discriminate all of the physiological signal, maybe we can understand more clearly. And now we try to develop some technique. For example, the independent component analysis. And so this is a low signal, and if we use the independent component analysis, we can reconstruct the very clear. This is the timing of the brain activation, and we can get the clear temporal pattern from the very noisy signal. So upper signal is just the average signal of the low signal. But if we use the ICA technique, you can see the very clear function signal. This is a period of the stimulation. Now we are thinking the mathematical technique is very important in order to understand the brain signal, because the human signal is very complicated, and probably that is a very important target in the field of mathematics. And now we are developing the platform of the signal processing for the distributing the user of the optical topography. Now this platform is completely free, and the user can change everything. And there are a lot of filters, and there are a lot of signal processing technique. And also we combine the anatomical, the signal processing of the anatomical registration with the temporal signal processing. And so in the next chapter, we are thinking about applied brain science. So things about the nature of the brain. This word was taught by the Gen Matsumoto. He is a very famous brain scientist, and this word is explained very clearly the characteristics of the brain. And the brain, he said, the brain is output type computer. The principle of brain processing is the memory-based architecture. The purpose of the brain is the production of program inside each brain. The